Hello and welcome to another Solana tutorial. Today we are in part 4 of module 3 of the Solana development course, and we're gonna talk about security. Must admit, I almost wanted to skip this one and be like, let's just go ahead with some anchor development because I want to finally get to that, and we will get to that. But security is a very important topic that we should talk about. In fact, it's probably the most important thing that I can teach you, because you will find out how to do things that you want to do. If you want to build a smart contract that does something, you will find out how to do that somehow. But it will potentially not be secure. So today we're gonna talk about some common security issues and things you really need to do when building Solana programs. Some things that you should not forget, because they might result in vulnerabilities that can then be exploited, and you don't want that. Because that's the thing, when we're dealing with Solana programs, we are always dealing with some form of value, even if it's just the sol that is used for rent. And usually you deal with more of that, right? And there's always something that can be exploited, and you always want to be careful. There are levels of that, but I guess we'll get into that. We will jump right in and have a look at creating a basic program part 3, basic security and validation. Yes, validation. Good. So, James, what we're gonna learn today? We're gonna explain why it's important to think like a hacker. Thinking like an attacker. I guess it's just a mindset thing. You don't think, did I do that right? How can I break this? And then you try to actually break this with a different mentality to the mentality that you wrote your code in. That's the entire reason why I do the game of death. That's hacking challenges, where you break my contracts. And I design my contracts in a breakable way for you to see how you can make them break, such that you get that into your mindset, that you think like an attacker, such that you also attempt to break your own smart contracts, which, if you manage, you can fix it, and that increases the security of yours. That's why we're doing all this. We want to understand basic security practices for Solana programs specifically. We want to perform owner checks, and we want to perform signer checks. Yes, those are two of those practices, and we'll get to why that is important. We will validate accounts passed into the program, and we also perform basic data validation. Yes, so the input data validation, because input data and accounts is just something that the user, or the client side, the attacker really can pass in. So if you don't check for all of those things, then that could turn out really bad. So today we're gonna learn the basics of that. Thinking like an attacker means, how do I break this? You want to ask yourself the question, how do you break this? You should perform owner checks to ensure that the provided account are owned by the program that you expect. Most of the times that's ensuring that the account is actually owned by your program, and you can also check that it's the right address, the right PDA that you would expect there. But it doesn't have to be your program ID, it can be the system program or the token program, where just double check that it is owned by the actual program that you expect it to be owned by. Then, signer checks to ensure that any account modification has been signed by the right party. In the transaction, we provide the signers, but it's up to the program to actually check for those signers, right? Solana itself, like the blockchain, they don't really do anything with the signers, except that you have to pay per signer for the actual transaction fee. But other than that, a signer is just, here's the signature for that signer, but that's about it. Like the blockchain, the validator, they don't check anything. The programs need to check if a signature is provided. Like, for instance, the system program checks that signatures are provided if they want to transfer Lamperts from one account to a different one. If the system program wouldn't check the signer and just accept any account that is provided, then, that would result in anarchy and everybody just transferring funds to anywhere, and the entire blockchain won't work. So it's important to check for signers. It's the program's task to do that. Your program needs to check if that party signed, if it requires that party as a signer. And that's essentially just, you need to know when only that specific address is allowed to do something and you require the signature for them. Then account validation. Basically, if you expect a certain account, making sure that it is that certain account. So for instance, if you've derived it to be a PDA with certain seeds, then you can check again if that actually matches the account that was put in there. When you expect a certain PDA in any of the accounts, let's say in your first provided account in the instruction, you expect a certain PDA, then you can do a check that it's actually the same address as you would if you derive it with the same seeds. And you can do, more custom checks. For instance, that it has a certain data length, or that it has a certain Lampert amount, or that it has, essentially you want to check if it's of a certain type of account. So if the account is a certain type, and sometimes you can defer that by the length. And if you use Anchor, they use an 8-byte discriminator in front just to do that account validation stuff. That's why 8 bytes in Anchor are just reserved for that on every account. But you can build your own stuff to do that, or at least check the address and the owner. And then data validation, essentially just checking all the data that comes in that is valid. And by valid, I mean that it is what you expect. Overview. We were building on the movie review program. The thing is though, it's great that we built that and it's working. We got it working. And the problem is sometimes people stop there, right? Yo, it's working. We don't need no testing and we don't need no security, which is bad. You want to avoid exploits in your program. You want to avoid people just misusing the program, doing other things than you intended for them to do. And so we need to build in some checks and assertions and security features or something. All of those. Remember, you have no control over transactions that will be sent to your program once it's deployed. Yes, so anybody can put anything on that. Solana is a public blockchain as well, right? So anybody can interact with any of the programs. Like, your program is not hidden. It's all public. And even if you make it closed source and don't provide an IDL, you can still just check on chain what has happened to that program and then make your guesses what it does and just throw a bunch of transactions on that program, because all the programs are public. A bad actor might just try and steal stuff from there, or just mess with it, just delete everything. Maybe they're just having a bad day. It's like walking through a parking lot and scratching on the cars. Some people do that just to mess with you, even if they don't financially gain from it. This, by the way, as James notes here, is also not a comprehensive overview of program security. This is just the basics and the most primitive things that you should be doing when writing native Rust programs on Solana. Think like an attacker. Neodyme gave a presentation at Breakpoint 2021. Neodyme, by the way, they're a security firm, so they do audits. And I met a few of the guys from Neodyme in Munich. They're really cool guys. There's a video from that. You can just Google that. We'll get to the video here. You can check that video out. You can watch this video. The main point they're making is that you should think like an attacker and that all programs can be broken. That's also one of the things that they said. All programs, like everything, can be broken. That's the mindset that you should have. It's just a question of how much effort / money does it require for the attacker to break your system. Because you can have the best and most secure Solana program there is, but an attacker with sufficient funds could just spin up enough Solana validators to take over the network. Now, I'm not saying that that is likely, because it takes a lot of funds. So we're talking like state actors that would need to do that, I guess. But yeah, if like the US government decided to take down Solana and drain all of their funds, or even just get a denial of service, they could do that because they have enough funds. I'm not saying they will, I'm saying they could. So even if your program is super secure, an attacker with enough money will be able to break it, because there are other layers that they can attack. And now our job is to make it as difficult as possible. There is no 100% secure, but we want to get to a point where for normal hackers, it does not pay off to hack our program, because it would just be not worth it, because the thing they can get out is less than they would need to spend to attack us. And if that's the case, then it doesn't make sense for a hacker to attack us, therefore they won't do it. It all just depends how much value you store, and also if you're writing a program just for, I don't know, like I do, my Discord verification program. There's not much to gain there. So I don't need to spend too much time getting it secure. But there is still a little bit to gain, like the rent of the accounts that my program uses, or the rent of the program itself. It's always a trade-off. How much effort do we need to put in versus how much an attacker needs to put in to hack us? And James talks about holes. Close as many holes. So the standard things that you usually, or that many people get wrong, they're always similar attack vectors, and the hacker then knows those attack vectors, and we need to make sure that they can't use them on us. And not just that, even if we memorize all those common pitfalls, we always need to think like an attacker, because it might always be the case that we introduce some new vulnerability that has never existed before, just by how our accounts work or whatever. So as they said here, don't think, is it broken, but how do I break this? Then you can get an understanding of what your code actually does, as opposed to what you wrote it to do, because you had an intention, what you want it to do. And then if you read your code like that, then you see, oh, it's doing what I want it to do because I wrote it that way to do it like that. But then you need to think the other way around. But how can I now break it? How can I make it not do the thing that I intended it to do, or whoever wrote the program? That's thinking like an attacker. First, some error handling. It's important to know how to use errors in your program. All right, James, tell us how. So some issues we can handle gracefully, and for some we'll need to stop the program execution and return an error. Now, we've already seen the program error in previous lessons, like the last one that I overextended a bit and made it extra long. The Solana program crate has this program error enum with a list of generic errors, like the one that we saw last time, which was like an invalid arguments kind of an error. But we might want to create our own ones. So we can define our own enum and just derive from error. Then it's a Rust error type. Okay, so that's not Solana specific yet. That's just a Rust error. Each error type also has its own error notation. It lets you provide an error message for each particular error type. Okay, so with that, we provide the error message for that given type. So because here we're just in an enum, which has in this case two values or two possibilities. A node error can either be forbidden or invalid length, and text is too long is the description of this invalid length. So far, so simple. You just need to get used to this notation. We have defined our own error enum now. What then? The compiler expects errors returned by the program to be of type program error. Yes, we also saw that. Let's go to the playground. In our entry point here, we expect a program result, and that is either okay or the error with a program error. Here you see that. It's either an okay with empty set or empty tuple, whatever that is, or the program error. The program error is any of those: invalid argument, invalid instruction data, invalid account data. So those are some predefined program errors, or it can be a custom error, which has a U32. So that's your error code then. And to see how we make our enum to a custom error now, we go here, because that's what James does here. That means we won't be able to return custom error unless we have a way to convert it into this type. The following implementations handles the conversion. So we do an implementation from node error for program error. Impl for, I guess I'm gonna look in the Rust book. So impl for tweet. A tweet is a struct, and then you can have summary for tweet. There you implement this summarize interface, a summary, the trait, which we knew is an interface, and you implement that interface for a struct. That's how you write it. Just implement for. Okay, got it. Thanks. I can come back to this. I just always like to understand. So for our, but then what is this from? God damn it, another step. I should really read the entire Rust book. Don't need to understand everything completely. I guess it's fine. So anyway, so we implement a from, which has, so that's the trait. From is the trait, which has a from function, which essentially gets the type. So that's why we have this node error in here. So from this, that's the T, and then the T is here, and T in our case is node error. So from our custom node error enum. We have a from for the program error. So program error gets an implementation, the from method from a node error, which means that I can then call the node error forbidden into that then makes it a program error. Now, why does that work? There's still one magic step that I don't get. The actual implementation of this is that it just returns a program error with type custom program error. See this? With this specific value of the enum as U32. So I could provide like a starting value for my errors, which is something that people like to do. And then ESU32 basically just makes this my U32. If I provide nothing, I think it starts with 0. That would be 0 and 1. But I guess I could start anywhere by providing an actual integer value here. Still don't get how this into works. Does it automatically... What? And the generic implementation therefore is in the from. From T for U implies into U for T. That's where it comes from. Got it. Which means that into T for T is implemented. Okay, cool. So if I already have the thing that I need, then this is easy. Yeah, so this from T for U implies into U for T. Got it. One should avoid implementing into and implement from instead. And that automatically provides one with an implementation of into. Thanks to blanket implementation in the standard library. Well, cool. Now we learned that. Amazing. So we don't need to bother with the into. If we have the from, then the into works automatically. You gotta Google that to find out, because like this is just magic. I like to debunk that magic and understand. So because we have that from here for the node, have the from implementation for the program error, we can now go the other way around and from our node put the into, and because the program error now has the from implemented, the into works the other way around. So my node error, I can fit into a program error. Right, now that we understand the basics of errors in Rust, move on to basic security checks. This is now Solana specific and not a comprehensive list of all possible errors, just saying. But some of the most common issues or the most important things to do. Ownership checks. Check if an account that's used in your program is actually owned by your program. Well, let's say if you read data from an account where you expect that you wrote this data, aka your program wrote this data, then you need to make sure that you actually own that account. Because if you do not own the account, so if your program does not own that account, then it could be just any account that an attacker has passed in, and he just happened to write the same or similar data or something else, and it can't be trusted anymore. And you will read that data, and you'll work. If you work with it, then an attacker can spoof any kind of information that they want you to read. So make sure that you check that you own that account, because then you can make sure that you have written that data. And by you, I mean the program. That's the ownership check. Then the signer check, verify that an account has actually signed a transaction. So just because somebody puts in a sender and a receiver account does not mean that you should allow the transfer. The sender should actually sign for the transfer. General account validation. If you expect some kind of account, make sure that it is that kind of account that you're getting there. Data validation. The inputs provided by the user, so whoever creates the transaction, they can just put in whatever bytes as a data slice, and you need to make sure that those things are what you expect and that they are valid. Ownership checks, most important thing. Remember how every account has an owner, which program owns the account. Not the same thing as the authority, so who is allowed to use this or sign for this. The owner is actually the program ID that this account belongs to, and only the owner of the account can write to this account. For standard wallet account, the owner is the system program. For a token account, it's the token program. For one of your accounts, it's your program. And your program needs to be the owner of your accounts. So all the accounts that your program writes to, the accounts need to have the owner set to your program ID. And that's what you can check for. Because again, the user can input any instruction data that they want. Also any accounts that they want. And they can provide an account that looks as though it might match your struct or your data layout that you expect in this account, just that you still can't trust the data in there. And to avoid this, we need to check that the owner is actually our program ID. So a simple if that account.owner is not equal to our program ID, then we return an error. Simple as that. And yes, PDAs, whenever possible, is more secure than externally owned accounts, because for PDA, we can guarantee that our program is the only one that is able to write to those accounts. I'm not actually sure if you can change the owner. That's something that I would need to look up. If I have the private key for an address and I create an account, I can assign an owner. That's when I call the create account on the system program. But can I change the owner after the fact? I'm not sure. But this, if I could, this could be another possible attack, which is why a PDA is more secure, because with a PDA, I can't do that. A PDA, I can't create beforehand with a different owner, or an attacker can't. I would need to do it from the program, from my program. The runtime grants the program write access to the account if its ID matches the owner. Runtime allows clients to transfer lamperts and, importantly, assign account ownership, meaning changing the owner to a different program ID, and anybody can read and credit the account. That's okay. So apparently, yes, you can change the owner. Or does it just say it's all are owned by the system program until they are assigned to a different one? Still can't fully tell even by that paragraph. Does it now mean only from the system program to any program, or if any program holds that and signs once again with the system program that I can change the ownership to someone else? I don't know. But well, if I own the account, I can write to any of its fields, and owner is just one of its fields. So if I own the program, similar to just adding some lamperts to them, I can also just change the owner. I mean, with the lamperts, the runtime then makes sure that the sum of all changes equal to 0. But with the ownership, I can I would assume that in the program, I can then just say new owner, which would make sense. So let's just assume that yes, we can change the ownership of an account. Even if we now own that account, potentially somebody else might have owned it before. And if it is not a PDA, so if it wasn't derived with our program ID, then that's still a possibility that even if we do the owner check, it's still data that an attacker wrote. That's why PDAs are more secure. Signer checks. A signer check simply verifies that the right parties have signed the transaction. Yes, because in the list of transactions, we always have is it a signer, is it readable, is it writable, and is it executable? And we have the individual signatures. In the note-taking app, for example, we would want to verify that the note creator... So for instance, with this note-taking app that James has there, the update instruction should be guarded by the actual creator of the note. So only the guy who wrote the note is allowed to update it. And we can make sure of that by requesting a signature from the same account again. Otherwise, everybody can update everybody's notes, and we don't want that. Because again, we can pass in any public key as this account. Check, again, pretty simple. If account is signer. So the is signer checks if it's a signer in our transaction, and then if it's not, we return an error. General account validation. So after checking owners and signers, we want to check that the accounts are actually what we expect them to be, so that they are the addresses that we would expect them to be. For instance, if we expect a PDA, then we can do so by checking when we put in the same seeds that the same address comes back. So for instance, we can do the find program address inside our program with same seeds, the initializer, title, program ID, and then we can check that this is the same as this, so account.key. If it's not the same, then again we return an error. Right? So we expect this specific PDA to be in this account. When we did that stuff with the next account, if we expect the third one to be our PDA, or in this case, if we expect the second one to be our PDA, then we just, check that this matches the actual PDA that we would get from find program address. And here we might actually want to use the find program address and not the bump from the account itself where it stores the bump, because that could again be a hack. Data validation. Similar to validating the accounts, we also need to validate the data, because again, that's just what the client, so a potential attacker, provides into our transaction. And that's now very program specific, right? Since you get in any kind of data, you need to know what you interpret that as, and then make checks accordingly. So for instance, if you have any sorts of limits, like 100 is your maximum agility, then you need to make sure that when adding your new agility, you're still at or below 100. And if you're bigger than 100, then once again, boom, program error. And this is a custom program error now with the into, or if you just trying to allocate more than you're allowed to in one go. So you need to make sure that your data is consistent, which means that it sticks to the constraints that you put on it. Like, you have assumptions about your data. If you say my agility is never bigger than 100, then you need to make sure that that is the case. And it's not just a data inconsistency thing, it's also a security loophole thing that could result from that. If you assume that, and then you have other assumptions that leading to whatever, and if an attacker managed to break those, then you're screwed. And you don't want to be screwed unless you really enjoy that. James gives an example of staking NFTs based on some attribute points, or for instance your agility here, and the more agility your NFT has, the more rewards they get. And if a user manages to pump up their agility to over 1,000, then they can quickly drain your treasury if the rewards are based on that number. Gotta be careful with that. Also, integer over and underflows. This is an issue in C, and it's also an issue in Rust, because integer numbers have their fixed length, right? Simplest is for a byte, we just have 2 to the power of 8 values, so 0 to 255, both inclusive. Now, if I have 255 and I add 1, then I would get to 256, but that's already 1 bit outside of my byte, which is ignored, and I fall back to 0. So even if I add something to a value, I might end up with a lower value because of an integer overflow. Same way the other way around, if I have 0 and I subtract 1, I suddenly end up with 255. And that is something that you need to take care of. And that's just with U8s. It's the same with U16, U32, U64. It's just a higher value that you have to then overflow. So if you store some data and you have some user input on how much to add to that data, it's not enough to just check that the user input is a positive number, because, positive number plus positive number is a higher positive number, you might think. But no, in computer science, with integer overflows, a positive number plus a positive number can actually be a lower number. So I might just add, if it's a U32, then I might just add the maximum value of U32, so 2 to the power of 32 minus 1, and then suddenly I subtract 1 instead of adding something, if I just do the simple addition. How do we mitigate this? Either we have logic in place that ensures overflows and underflows cannot happen, so we need to know how large are our numbers, and we need to make sure that they cannot result in an integer over or underflow. So for instance, I just have unsigned integers, then I can be sure that there are no negative numbers, plus I make sure that they are both lower than a certain value, and then when I add them, nothing weird should happen. Or second possibility is I use the checked add instead of the normal plus, so I can be like checked add this plus this. Then I can be sure that this results in an error if an overflow happens. Don't know what kind of error that returning none if overflow occurred. It's an option, not a result, okay? If there is a value, then it's some, and otherwise it's none if an overflow happened. And then if it's none, I can return an error manually myself. Yeah, so overflows, underflows are also classic attack vectors. Moving along. Now to the demo. Let's practice this together, yes, with our movie review program, yes. We store movie reviews in PDA accounts, and we finished all the basic functionality last time. Still have it here. That's my movie review program. And we'll now add some security checks to the functionality. We find the starter code here. We've separated into librs, entry point, and processor. librs now only registers the code's modules. Entry points only defines the entry point, and processor only handles the... Okay, that's fair enough, James. We've also added an error file with our custom errors. Should we use the code that James provided? I guess so. Wow, if I click here, it gets me to Playground. That's James's program directly in Playground. Okay. So he separated that here. He just has those public module thingies now. So use this, use this, use this, use this, use this. Here is just the actual entry point with the process instruction, and then processor process instruction, and the processor then contains yet again a process instruction which matches the instruction. There's just one add movie review, and that's the actual code for it. In state, we still have our state stuff. Sealed for movie account state, I don't know what that is. And he added some errors rs, which is empty for now, so we will need to write that. Okay, fine. Cool. Right, so we've now given each account 1000 bytes. So not the minimal length for the data, but just 1000 bytes, such that we can later quickly resize it. There is a realloc method now, but we're not going to use this in this demo. So we just have a larger than necessary account per default, such that we can do the update. Oh, here he talks about what that is. Perfect. We want the ability to check whether an account has already been initialized. To do this, we create an isInitialized that checks isInitialized. Okay, fair enough. Sealed is Solana's version of Rust's sized trait. Okay, so he would just say that it has a fixed size, so it can do some optimizations. Fair enough. Let's move on with our custom errors. Open the file and add errors for each of the above cases. I don't want to just copy that, of course. I want to try and write it myself to see if I remembered. So it would be something like an enum or my errors, or what would I call it? Movie errors, something like that. And inside this enum, I can then define my, what do we check for? Update instruction has been invoked, hasn't been initialized, like a not initialized yet error, or doesn't match expected PDA, doesn't match PDA error, something like that. And each of those were something error, and this was derived from error. And here I have a message, something along those lines, but not quite that. And I guess here derived from error. Hey, I wasn't so wrong. Pretty on point, except that I also need to import that stuff. I would say is not initialized or something proper, but all that, I don't want this to be a typing exercise for me, so I'm just gonna copy. Aha, he also derives from debug. I don't know what that does, so that's what he did. Review error, movie error. Oh yeah, having it a singular is probably better because it is one error. It's not a collection class or enum. Yeah, this looked similar to this, and this looks similar to this. So I'm happy with how I did. I managed, and I will now use what you said, James. Uninitialized account, invalid PDA, invalid data length, and invalid rating. And he already had the comments for 0, 1, 2, 3. So that's going to be our custom errors. Speaking of custom errors, to make it an actual program error, we need to implement the from trait for the program error. So how did we do that? We implement the from for our review error for the program error. And program error we need to once again import. Don't need to know that by heart in which crate that is, because that is easily Googleable. Unable to format file. And this trait looks like the following. I don't get the suggestion, so I guess it was a public from. Oh, function, of course. fn from t to self. fn from t to self, and self in this case is the program error, which essentially just returns a new error. I wish I had completion. Review error e and e dot or esu32, something like that. It was something along those lines. Really hard to program without autocompletion. It's like driving in the dark. Like I don't know where I'm going. Yeah, so return a program error, and with this implementation that will then also give us the into on the review itself, because Rust magic. Let's see how we did here. From, you know what, I'm just gonna copy this. It's a E double point. Yeah, I should have seen that coming. And the rest looks good though. The rest looks fine. I mean, that I make it an error of this. I don't need that apparently, because program error obviously is already a program error, and I don't need to, like, I could call it self, but we are inside program error anyway, so it's fine, I guess. And now it looks the same, except I have a return here, and if I don't have a semicolon, I can also leave that out, but you know, it's the same as this, so I think that's fine. Let's see if that builds. Yeah, cool. Moving on. Inside our processor, where we have this unused import program error, kind of just gonna do this. There we go. No warnings anymore. But here we now want to use this review error. Crate basically means the same crate, I guess. So I guess I could leave that out as well. For consistency, I keep it because all of them do it. Adding security checks to add movie review. Now that we have errors to use, let's implement some security checks in the add movie review. For instance, a signer check, that the initializer of a review is also the signer on the transaction. Okay, we can do that. So in our processor, in the add movie review, we want to make sure that the initializer is also a signer of the transaction. So we would do something like if not. And I think that's just one field inside this account info thingy. What's the type of this? I don't even know. Account info. Yeah, it's just a field is signer, a boolean. If not is signer, and Rust doesn't want us to do round brackets around that, but here's some curly. Then we just return, do I here need the error of into? Yeah, we return error of a program error. Missing required signature. Oh, that's a nice one. Let's take this one. Program error, missing required signature. Does that build? No. Program, oh yeah, because I'm not importing that anymore. Now I am. There we go, build successful. Yeah, we don't use that error yet, that's okay. That would be my guess on how to do that. How did I do, James? Error, program error, missing required signature. Nice score, exactly what he did as well. Might as well add this message, a nice little message. Okay, and then we say this is completed. Moving on to account validation. Let's make sure that the PDA account passed, and don't worry, I'm not looking at this code. I'm literally just looking here and reading and having it high enough that my head is not in the way, but I'm not looking at it yet. The PDA account passed in by the user is the PDA that we expect. We derive the PDA for a movie with our seed. We return an invalid PDA error. So, right, that's complicated because I now need to remember what the seeds were. But anyway, it goes like this. I get the PDA and the bump, which I ignore from, it was definitely in public key. Oh wait, it's already here. Oh, that text is already here. Oh, cool. I don't need to remember all of that stuff. Perfect. I'm literally writing the same as, okay, cool. Cool. I have the PDA already here. It's already deriving that as well. So all I need to check then is that the PDA is the PDA account. So if PDA is not equal to the PDA account dot key, probably, because that again is an info like we have here. Key, it's a field. I think Rust does the magic with automatically deriving it, automatically dereferencing it. So I don't think I need this, but I'm not 100% sure. So if those are different, then once again, I do something like this. Say, get me the right account, please. Yo. And this time we use the review error and we use this one, invalid PDA. It's a lot of copying if I don't have autocomplete, but well, that's that. Yeah, I guess that's it. Does it compile? No. 2 errors. Oh, of course. Now we're not a program error, so we need to into this. See if that fixes that error. Yes, now we have only one more error. Mismatch types. We get a struct public key and we found a reference. Okay, fine. Then we do need to dereference that. Fine. Okay, you answered my question to whether or not I need to dereference this. I need to. There we go. Now it compiles. Next up, data validation. Now let's perform some data validation. We start by making sure that rating falls within 1, 2. You know, actually, this whole entire thing is only fun, really, if you first exploit it and then you do the fix. But if I do that, then this video is going to be 2 hours long again. It would be fun to just do the exploits first and sign as anyone, just to demonstrate that you need that kind of validation, or putting in a rating larger than 5. I challenge you to do it yourself. Before you actually put in your checks, first exploit them and then mitigate them. But yeah, anyway, we are at data validation. We want to make sure that the rating is between 1 and 5. So yeah, just do a if rating less than 1 or rating larger than 5. Again, only ratings from 1 to 5, please. And the error will be an invalid rating. That's pretty simple. What else? Or lower than 1. That message is misleading. It could also, because it's also printed if the rating is 0. Just saying, James, just saying. The next thing we want to check is that the contents is less than our 1000 bytes. I think I would know how to do this, since we did this last time as well. James, you're missing semicolons. Here needs to be a semicolon because otherwise this is returned. Just saying. Yeah, it's just another data check, right? So here's the data that we have. We need to make sure that it's less than or equal to 1000 bytes because we don't have more space on the account than this. Lastly, checking if the account has already been initialized. And that's a function we've already implemented in the movie account state. So here there is a is initialized movie account state struct because that's the add movie review. We definitely have not initialized it yet. Where should I do that check? I mean, I can do it here. I'm okay with that. Maybe I should and doing it down here when I already serialize it again, it also doesn't make sense. So this check only makes sense for the update, not for the add, because I write it and then asserting it myself that I already wrote it. That's doesn't really make sense to me. Oh, you check if it is already initialized. Ah, that makes sense. Ah, see, I would already have a... Yes. I see, in my assumption, the account is not initialized. And then it didn't make sense why I need to check that, right? But if it is initialized, then I need to abort here. Then I should not just overwrite it because we're adding something. We're assuming that it is not initialized. So I need to check for that. If it is initialized, then throw the error. Haha. All together now. That's what it looks like. Support movie review updates in movie instruction. Ah, now we want to allow for updates. I guess this I am gonna copy because the focus of this lesson is the security checks. This is a security check. In the instructions RS we add this. Instructions, we add this. And in the unpack we match a variant for one this. Essentially the same, but for the one we do the update. Pretty much same data otherwise. And then we define an update movie review function. So in the processor, when we match here, we now also match for this. Because if we don't have that, it won't build because it tells us no method, the following trait implemented, but not in scope. Perhaps add use for it. The match instruction is not fully covered, so we're missing the update movie review. So in here, we're missing the branch for the update movie review. So I'll do that. But now I don't have this update movie review function. And again, I'll just steal it real quick and even steal the entire implementation because can't be bothered to. Let's put it down here. Implicitly returns nothing. Okay, that's fine. So what we just did is we get an iterator for our accounts, iterate over our accounts. We expect the two accounts, Initializer and PDA account. We don't need the system program anymore because we don't need to create the account again. So the system program does not need to be part of those anymore. And then we can essentially do the same as we did in the add. Here we unpack and then we set the new data and then we serialize again and then we return okay. So I'm just going to copy that from above. And the only thing that we do differently now is we do the opposite check. We don't check if it is not initialized. We check that it is initialized. So if it is not initialized, then we throw some custom error. Back to our processor into the update movie review. So if it is not initialized, we throw this. Otherwise, we update. And the setting to true we don't need because it is already there. And then we serialize again in the same way that we did also last time and in the add movie review. We also want to perform some more checks like the ownership check. Verify that this PDA account is actually owned by us. If not, we do an invalid owner, which is again a program error. We would do that right up here, why not? If this PDA account, because that's where we're reading data from and we want to make sure that we own that data, we were the ones that wrote this data. So one part of this is making sure that we own it, the account. If that is not, in fact, the account dot, let's look that up again, what do we have here? Account dot owner, it's a field in the accounts info thingy. So account dot owner, if that is not our program ID, which we totally get from, where do we have our own program ID? How do we get our own program ID? If I write it like this, I'm pretty sure that you don't know what that is. Oh, you do. Did we define that somewhere? Oh, yes, here. That's one of our parameters that we get from our entry point, of course. Yes. Here we get our own program ID. All right, cool. There we have that. And we return program error, invalid owner. Build? No. Variant or associated item not found in program error. In fact, invalid owner is not one of those. That's true. Incorrect program ID is kinda that. Yeah, at that point I would make myself a custom error or do something else. This is the closest one to what I want to express. And I could just do a custom error, but I'm too lazy. Now let's perform a signer check to verify that the initializer of the update instruction also has signed that transaction, because otherwise anybody can just put that public key as an initializer to be able to change that, but not have actually signed it. So they don't need to actually own the private key to that public key. We need to check that they do own the private key by checking that they are a signer. And that's, again, pretty straightforward and simple. This initializer here, which just say, if you're not a signer, then piss off. What do we return? Missing required signature. Ah, that's a good one. Missing required signature. There. And then again, the same thing with the PDA. That's literally the same as we had it above. So again, I can copy that from here. That's the same code. I mean, I could even make a function for that. I find program address with those things, and then I check if the PDA we get back is the same as the key of this account. Oh, it's called isSigner, right? Yeah. Basically double the work what we're doing here. Then we unpack it. If it's not initialized, we say uninitialized account. I already did that earlier. And then again, the same checks with the rating and the same checks with the length. So again, those checks are the same as above. So really what we should be doing is a nice check data function that checks all of those things. Because otherwise we have duplicated code. Like this I duplicated, this I duplicated, and now I will also duplicate this. So really, we should put all of this into a security check function. Function security check would now check all of those things. And it would take all of those arguments, PDA account, just to practice some Rust and working with references and stuff. So we check if it's the signer, we check the account, where was the owner check? Owner check we also put down here. So owner check, signer check, account check, data check. And this, now what does it return? It returns also a program result. How do we do this? Because if it's an error, then it should be returned, but otherwise I don't need I'll just use a result. I can use a program, hold on, I can use a program result, but then the way I want to call it, so those are all the things that we did down there with the security check. That takes the program ID, initializer, PDA account, and then title, rating, description. This thing returns me a program result, and I want to unwrap this because that will then throw me, or actually I can do this. It will return me the error if there is an error, and otherwise it will continue and give me the result, but the result I don't care about, like I won't. So it's not nice to do it a program result then. Should we just go with a result? But whatever, no, I'm not a pro. I don't need to, yeah, it's fine. Same thing we do up here to avoid duplicated code. We still have duplicated code with this part and this part, but you know, that's fair enough. Yeah, so our security check checks the owner, the signer, that the account is the address we expect, that the rating is valid, and that the length is not too long. Good. Oh, I don't update the title. That's true. Don't need to update the title here because the title should stay the same. Don't need to update the title because also the title is part of the PDA. Let's test all of this. For that, feel free to use this front end. Let's go build. Oh wait, it doesn't even build yet. Hold on, we're not at all done. I copied out too much stuff. This is one of them. Then I need the bump seat outside as well. I guess I need to do that outside. Then let's do that here. And just provide the PDA as another field. I could make it optional, and if I don't provide it, then I do this code again. but I'm too lazy for that. Like, I'm not gonna actively really use that anyway. So we have an issue with, can I just make my title, rating, and description all references? And then for the security check, I'll just use references. If I borrow that to make the comparison, it would make more sense to this, right? Yeah, successful. Except that in this case, we don't use the bump seed, which I understand because for the update, we don't need the bump seed. Here you go. And then it should also build without warnings. Yes, we're building without warnings. Perfect. So now that we have this, finally, we can deploy a program. Should we deploy it to this same address as I had it last time? Let's try. Cool, that did work. We do have also this address in here still from last time. So now I can run dev. There we go. Cool. Let's go to localhost then and see if I still have my accounts from last time. No, it doesn't even compile. That's not good. We also had that last time, right? And we ignored it, those 6 arrows. And it worked just fine. So we still have Andy's home movie here and the Solana tutorial, which is amazing. It automatically makes it a 5. I can't even use the front end to... Anyway, submit. Please connect your wallet. Okay. Ah, there we go. Now it looks better. Now I can approve this. Submit it. Bam. Okay, nice. Now this seems to be working. And if I refresh and ignore those errors, then I see my review here. Okay, cool. Did I put in the wrong way around? Movie title as the title? Oh, that could be because James does it the opposite way of me, I think, in the order that he stores the title and the description. I remember. Yeah, so what's happening here is that this is now in the wrong way. My review is actually stored as the title. Oh, that's fun because I wanted to be different and I was different. Anyway, I'm happy with this. I mean, we did the happy path. Let's at least check 1 or 2 of the unhappy paths, like which one is easy to break. I mean, the owner is hard to break because I would need to write another program. Putting in a rating, the front end doesn't even allow me that. Putting in a too long, I mean, that's relatively simple to check. So if I have long, and then I just need more than 1,000 characters. So let me just copy this. Is that more than 1,000 characters? How about bytes? 2,000. There. Movie review. There. That's my review. Submit. What the hell? I already get an error on front end. Come on. Allocate 1,000. Make it 6,000. Oh, maybe then the transaction is too large. Oh yeah, my transaction is also only limited to 1,200. So I can't even, oh man, 1,002 bytes, please. Just that narrow window of not having too much data, but also not too few, to still fit it in one transaction. Huh? You know what, I'm gonna make it easier on myself and only allow 100 bytes, make the account smaller. Give me 200 bytes then. There we go, that seems to still work. Oh, that worked. Interesting. So if I were to load my accounts again, is it there, that lorem ipsum? Yeah, so my check did not work. Actually, let's always print that. Let's print the length as well to see. Maybe the way it counts bytes is wrong. Maybe it's UTF-16 and not UTF-8. Let's generate another lorem ipsum with 200 bytes. This will fail now. Custom program error. That looks better. Data length is 215. Data length is larger than 100 bytes. Data length is 215 now, larger than 100 bytes. And so I get the custom program error 0x2, which is that one here, the second one, 012. The input data exceeds max length. So that worked now. Don't ask me why it didn't work or worked before. Maybe the upgrade didn't go through, or it still used the old program, or something. I don't know. Last thing I still want to check is if the signature check works. So this, because that's an important one. And then I'll call it a day. So I want to now add something as an owner. Let's change our front end a bit. So here the public key, handle transaction submit foreign key. That's the key that I want the program to see as the initializer, even though I initialize it as someone else. So I just make myself a new public key. Should we take a specific address? Let's do something fun. Let's use the system program. Let's pretend the system program is doing this. The system program, that's my foreign key. And instead of now using my public key in this PDA creation, I use the foreign key. And also here in the instruction, I provide the foreign key. And because I can, right, so that's the instruction. And since I cannot sign for this one, I have to say not a signer. Writable will also be false because I don't need to. I will need to add another account though, which is now my public key. And I need to have it in that order, right? I need to have first the other one because that's what the program reads, right? They will read, where is that? Entry point. Here, instruction, processor. They will read the initializer. Initializer, next, next, next. If there is another program here, it doesn't matter. I could, like the iterator is not done yet. I mean, I could check here that this were all the accounts that there are, but I don't. So I can just have another one that actually signs. Maybe let's also lock this. This is the creator of the review, and I will call it the initializer. And then here I have the same checks, same security checks. Let's see. Account info display. Oh, wait, hold on. Of course, you need the key. Build, upgrade. Now back to this thing. If I add a short one, lorem, a better rating. Let's wait a little bit because otherwise the program might just not be ready yet. And I might still work on the old program. Maybe that was the error before. Then submit this. Missing required signature. Damn it! This is the creator of the review. 111111. And then it says missing required signature. So it did lock this though. We got here and then we're missing a required signature. Hey, wait, but that's exactly what's supposed to happen, right? I'm already so brain dead that, yeah, because that's exactly what's supposed to happen. I did have that check activated. So I'm not allowed to create an account where this is not a signer. Only if this is not there, if I forgot to check this signer, if I were to build and deploy it without that security check, then this should go through. Haha. Now, okay, I accept this. And now if I submit it, data length is 20. Writable privileges escalated. Ooh, cross-program invocation with unauthorized signer or writable. Oh yeah, because there's another issue. Because then here, when I create the new account, I put the initializer as the guy paying for it, and the system program won't pay for it. So damn it, bad example. But we already got here. We already managed to get in. If the account was already created and I would just update it, actually, let's update something. Let's update something that we don't own, because it's easy to update something. I mean, we have it implemented here. I just need to use it. And while we're changing the front end, might as well. In the data, that's the buffer. And the buffer is the movie serialize. And the movie serialize, we flatten this and the variant is 0. So let's make the variant a 1 for the update, not the add. That's it. If we do that, now first see if it works normally with my public key. If I have my public key, I want to update a movie that does not exist yet, then it will fail and say invalid account data for instruction. It is the right error. I was just expecting a different error, but that's the one that I returned because I don't own this one because it doesn't exist at all. So the movie I was trying to update here doesn't exist, right? And I was expecting a different error for some reason. So we need to find a movie that does exist, like the ASDF and review, ASDF and new review. Although I might now have it in the wrong order. Hold on. Ha! Look! Now that seems to go through. Hold on. That went through. Amazing. I can update. And now I have new review. Bam! The updating works. Amazing. Now, finally, back to my attack. Just use a separate wallet. I just create a new wallet. This is the owner. Andy is the owner of this review now. And I want to enable this signer check again. And in my attack, I put Andy now, public key, this guy, even though I don't have his private key anymore. I will now still want to change his review. The way I do this is I just put his public key here, but I don't sign for it. That's okay. I don't need to sign, and those are all the keys for the instruction. And then when I do the transaction, here I already sent transaction. Where do I provide the signatures for that? There I sign with my, hold on, I don't need to do that because I do that with the front end send transaction. That will do that for me, signing it with my public key anyway. Okay, cool. So I don't need to do anything about that. Okay, cool. So I just provide the Andy's key here. It's not a signer, it's not even writable, but you know, the PDA, that's also with his key. And I want to change his movie. Let's see if that works. It should not, because I have this check enabled again. If I go ahead and not from this wallet, let's disconnect and connect to the different wallet. So with my safe house wallet. If I do the ASDF movie again, attackers are amazing. And I submit that, then I should get the invalid signature kind of an error. Yeah, missing required signature for instruction. That's what we expect, right? We're missing a signature because we were so smart to check that here. If I forgot that check and I build and deploy, going back here, doing the exact same thing again, and suddenly it will work. Look at that. Ah, isn't that nice? And now as this wallet, who does not own Andy's private key, I changed Andy's movie review because there was no signature check. Attackers are amazing. There you have it. There you have it. Attackers are amazing, but so are devs, and we are smart and we keep that stuff in. Nice. I think that's enough for today. I'm happy. We discussed some security vulnerabilities. We discussed why it's important to check the owner, check the signers, check the data, and check the accounts. And even more than that. Do even more than that. Those are just the basics, the most primitive security checks that you can do. Of course, it doesn't end there, but it ends nowhere. But anyway. I have a Christmas party to attend because I'm still working for a company and they pay for my dinner tonight. So I'm gonna go. And yeah, you go check out the development course that James did. At the end, as always, there's a challenge for you as well. You do the same thing again for the student program, the student intro program. And then when you're done with that, come join my Discord. Sign up for the Game of Death. You can do that here. And then follow the challenges that I post in the Game of Death challenges, where you will also get to hack smart contracts and keep your hacker alive. I think with that I want to conclude. You can check out those videos, like this one, subscribe, and I'll see you in the next one because we're done with module 3 and next time we will start local program deployment. Or maybe skip that module and go straight into Anchor. I don't know yet, but definitely I will make more videos about this development course and teaching you Solana programming basics. And I will see you next time.